All right, so the Lumu portal is located at manage.lumu.io. I'm going to go ahead and log into the portal. And before I get started, I just want to mention that this portal was built with MSPs in mind. And by that, I mean it supports the things you expect. It supports multi-tenancy. It supports self-service, so you're free to create, delete, or modify the properties of your customer tenants. It supports multi-factor authentication, and it also integrates with several single sign-on solutions. So these are the things I know MSPs have come to expect in an MSP portal, and we have built it. All right, so deploy Lumu, we need to do a few things. We need to create a customer tenant. We need to assign licenses to that tenant. We need to begin to collect network metadata within the tenant. And then finally, we're going to add response integrations using your existing security tools within the customer network to orchestrate the blocks I talked about just a minute ago. So let's go through that process, what it might look like if you were going to deploy to a new customer. So we're going to go to deployment in the left-hand menu and click on tenants. And then we're going to go to the button that says create a tenant. So in this case, I'm going to create a new customer. I'm going to call the customer Acme. But I need to assign endpoint licenses to Acme. What are endpoint licenses? Endpoint licenses are assigned to any device on which our Lumu endpoint agent can be installed. The purpose of the Lumu agent is to collect DNS and IP metadata from the endpoint and send it securely to the Lumu portal for analysis. We can install this agent on Windows, Mac, and Linux devices. Note that things like IP printers, IP cameras, tablets, IoT devices cannot host a license, therefore they do not consume an endpoint license. Why is this important? Because the subscription model of paid Lumu is based on the number of endpoints licensed. So we're not charging for devices like IoT or tablets or IP phones, but we can collect network metadata from them, right? Just to make the point that we are licensed much like you'd be familiar with an RMM tool subscription, it's licensed by endpoint. So in this case, I'm going to assign 7 endpoints to this tenant Acme. What that means is I can deploy up to 7 Lumu agents to endpoints within the Acme network. So if I click save, I've created the tenant. You see the tenant appear. Now if I click on the tenant, you can see that the number of endpoints represents the number of endpoint licenses I assigned to Acme. What if I made a mistake? Well, self-service motion says I can edit the tenant. I can increase that amount. Let's say I needed 10. If I save the changes, I go back into the tenant. I then have 10 endpoints that I can push out into the Acme network. All right. So what I want to bring up first are some best practices for deployment. I always suggest that when you're deploying to customers, the first thing you deploy are Lumu endpoint agents. Why is this? Because you can use the power of your RMM tool to easily deploy 10 endpoints or 1,000 and gain network visibility very rapidly in a new customer environment. To actually use the RMM to push the software, we need to download the appropriate version, and we have to create an installation group. So in this case, I'll call the installation group Acme Endpoints, and I'll click Create. That gives me an activation code. I'll use this activation code when I'm pushing the software with my RMM tool to activate the Lumu agent on the endpoint so that it can then communicate securely to the Lumu portal. That's the first step. What do we do next? Okay, so we're collecting DNS and IP metadata on endpoints we pushed out with our RMM tool. What about those IoT devices, those tablets, those things that can't host a Lumu agent? Well, we have a few options. Let's say you have a customer that has an Active Directory environment. We can actually deploy a special type of agent we call a server collector. This server collector only goes on Active Directory servers running DNS in the environment. And the assumption is in the network, if you have Active Directory, the endpoints are pointed to these AD servers DNS for name resolution. So if we install the collector on the AD server running DNS, we will be able to get DNS metadata from things like those IoT devices, those IP cameras, etc. So to add a collector, we click on Add a Collector. We have to name the collector. Let's say it's the first Active Directory server called 81. So I'll give it a name. I'll give it a description. I'll click Create. I get a unique activation code for the server collector. Typically, customers deploy server collectors manually because unlike endpoints, you typically don't have 40, 80 servers. You usually only have a couple. So I just want you to note when you actually get this code, this is unique for each server collector. So if we had 280 servers that we're going to deploy server collectors onto, we're going to wind up creating 2 collectors and have 2 unique codes, one for each AD server. It's important that you don't share the code between the 2 servers. You can use shared codes for the endpoint installations like you saw in the group. Okay, so what if I don't have AD on-prem or in the cloud? What if I'm using Intra ID for my actual usernames and passwords? Well, we have another way we can collect metadata in the network without a server collector. For that, we use a Lumu virtual appliance. So our virtual appliance is pre-configured that collects network metadata of various types. It can collect syslog metadata from firewalls. It can collect NetFlow from network devices. We can collect proxy logs and even DNS in certain cases. We support all common hypervisors, VirtualBox, VMware, and Hyper-V. I won't have time today to show you the actual process of actually standing up a VA in a hypervisor environment, but I'll kind of walk through what that process looks like. So let's say I'm going to want to collect syslog in the network because I'm using Intra ID and I don't have Active Directory, so no server collectors. And I'm going to deploy this on Hyper-V hypervisor, right? So I'm going to download the virtual appliance image to the machine with the hypervisor that we're going to run it on. In the portal, I'm going to create the virtual appliance. So we're going to call it my first VA, and we give it a description. This is going to give us a unique activation code for that virtual appliance. The next thing we would do is we would go to the Windows server running Hyper-V. We would import the Lumu virtual machine. We would boot it up, turn it on, and it's going to ask us to log in, configure networking, and I highly encourage you to use a static IP, or if nothing else, DHCP by reservation, so that the IP address of the virtual appliance does not change. It will then ask you for the activation code. If it has networking functioning properly, it will reach out to the Lumu portal and it will activate the virtual appliance. So as you can see here, if we go back to the status of the virtual appliance in the portal, it's currently showing as inactive. That's because I haven't created the virtual appliance, stood it up, activated it, so it hasn't checked in to activate. So once it does check in, the status will go from inactive to active, and the light will turn green. So we're trying to collect syslog, right? So how are we going to do that? We've got the virtual appliance active. It's checking into the portal. We need to add a collector. So we have various types of collectors for the virtual appliance. I mentioned syslog as one of those. So let's say in Acme's network, they use a FortiGate firewall. So I'll call the collector FortiGate, and when I select the type of collector that we're adding, I'm going to pick firewall log or syslog. Note, you can see, like I mentioned earlier, we can collect NetFlow, proxy, DNS metadata with the virtual appliance as well. In this case, I'm going to want to focus on syslog. I click Save. And if we take a look, we've added the collector in the portal, but we haven't seen any traffic. That's because the work isn't done. We'd go back to the virtual appliance, run a few commands. We tell it, hey, go to the portal and look for new collectors that have been added. It sees this new collector and it says, tell me about it. We say, I'm going to be getting logs from a FortiGate firewall. This is going to be UDP traffic and I want to collect it on port 1514. And then we're going to set the time zone related to the collector so the timestamps for incidents that appear in the portal by way of syslog collection will match the appropriate time zone. We're then going to go to the FortiGate firewall, and we're going to configure syslog to be sent to the IP address of the virtual appliance. That's why it's important to have that static IP. Once we're doing this, we will begin to see traffic come into the collector, and it will move to a positive number and turn green. Okay, so at this point, we've deployed the Lumu agent for endpoint visibility. If we had a server collector for AD servers, we've deployed that. If not, or maybe we still want to collect syslog. We do that. We can still do more. I suggest that customers do this in every tenant, and that is to add a special type of integration for email. So Lumu has 3 different types of integrations. Collecting metadata from email falls into the data collection category. So this is also where we collect metadata from things like Cisco Umbrella, cloud VPCs, but in this case, I'm going to focus on email. Let's say the customer uses Office 365. I want to collect the email metadata for that email tenant. To do that, I'm going to click Add. I'm going to activate the integration, and basically it is going to ask me for a global admin account that it can use to actually set up and activate the API integration between the Office 365 tenant and the Lumu portal. Once that's done, we're able to analyze the email that comes into a user's mailbox. This is after, let's say, it's been through a Proofpoint, a Mimecast, an Area 1, and it made it to the user's mailbox. We know that phishing attacks make it through email security tools all the time. So what we're looking at for an email that reaches that user's inbox is we're looking at metadata in the email. What are their IP headers? Where did the mail come from? Are there any URLs in the body of the email that contain URLs that reach out and talk to IOCs or adversarial infrastructure? If there's an attachment in the email that a user clicks on, does it direct them to a site or URL that is a known IOC? We can take this data, and using our response integrations, if it triggers an incident, we can pass back blocks to things like your firewall or your EDR to prevent the IOC from actually getting into the network. So the other types of integrations. I'll bring up SecOps. SecOps is basically where we can connect Lumu, let's say, to your PSA. Let's say you're a ConnectWise shop, and you want to connect the Lumu portal to the ConnectWise ticketing system. We activate this integration, and if an incident is generated in the portal, not only will the portal users receive an email notifying them of the incident occurrence, it will also generate a ticket in ConnectWise that an engineer might use to add notes, bill time, and they can even close the incident directly out of the PSA rather than the Lumu portal. It's a bidirectional integration. So if you close the ticket in ConnectWise, it closes the incident in the Lumu portal. If you close the incident in the Lumu portal, it can close the ticket in ConnectWise. SecOps is also where we can get information, let's say, from a SIM, or we can even transfer information from an incident to a SIM. The last type of integration is a response integration. So these are the tools that do the blocks, right? This is where you're going to find your firewalls, your EDRs. You're going to find DNS security tools like Umbrella, which can block URLs, web proxies, that sort of thing. So let's take, for example, that Acme has a FortiGate firewall and Microsoft Defender EDR. So if I activate this response integration for Acme, and I pick all the different threat types here, and I choose to also generate a block list for IPs and click Create, this is going to activate 2 URLs that are hosted at the Lumu AWS infrastructure that we're going to configure the FortiGate in Acme's network to go out and check. We're going to add these external connectors. One connector is going to point to this URL, and another connector on the FortiGate is going to point to this URL. If an incident occurs that has either a URL or an IP to block, we're going to block URLs on the FortiGate using the FortiGate's web filtering capability. And we can block IP addresses by creating a firewall rule that basically says if it's going from the LAN to the WAN and it's trying to get to a group that basically is defined by that connector, block it. So we're able to block URLs and IP access on the firewall as an incident is detected. So let's take a look at something like Microsoft Defender EDR. If we add this integration and activate it, much like the 365 email integration, it's going to ask us for an admin account. We're going to supply the credentials, and it's basically going to go out and activate the API integration to the Defender portal. We'll go into the Defender portal, make sure indicators of compromise are turned on, and now we have connected via API the Lumu portal to the O365 Defender portal. So if an incident comes into the portal that happens to contain either a URL, an IP, or a hash payload that we need to block, Microsoft Defender is capable of blocking all three of those things. So we will send back a URL, an IP, or a file hash, or all three, to block by Defender EDR. So now that we've pretty much summarized what a typical deployment looks like, we've deployed endpoint agents, we've done server collectors if applicable, we've deployed a virtual appliance, we're collecting syslog or NetFlow, and we've configured our response integrations for this customer's network. We're done with the build out. There's no tuning to this, there are no rules to adjust. Once we're collecting metadata and we have the response integration set up to block, we are good to go. So I told you I tied this all in together by walking through an incident in the Lumu portal. Note that incidents are in a separate section of the MSP portal. They're under operations. If we click on incidents, the incidents are basically also categorized at a tenant level. So in this case, I'm going to walk through a sample incident that I triggered earlier in the week, located in Lumu Inc. And Lumu Inc. has gone through this deployment process we just discussed, right? We're collecting metadata in the environment. We've got response integrations configured. So we're able to show the power of Lumu and how it orchestrates these blocks in near real time. So the incident I'm going to focus on today is mojobiden.com. If I click on the incident, I'll walk you through the incident, how I would work the IR or review the incident. We're going to start basically in the detections tab, but we're going to see that the IOC is mojobiden.com, which contains black matter ransomware. So obviously the purpose of this ransomware is to get into the network, try and gain access to files and encrypt them and hold you hostage until you pay them money to decrypt the files. So if we look at the detections and I expand out this home desktop, this is the desktop I triggered the incident on. It has the Lumu agent for Windows installed on it. And that's why it shows the source of the basically where it was, how it was detected in the network as the Windows agent. If it was actually the metadata was collected at, say, the ED server level, it would show server collector, or it might show syslog or firewall if it came from the syslog data we're collecting. In this case, it was the endpoint agent. We see the IP of the endpoint, the name of the logged in user of the endpoint, and we even show the process that touched the IOC. So in this case, I used the Edge browser to go to mojobiden.com. So any and all contacts and affected endpoints will show under the detections tab. The next thing I'm going to want to do as an analyst doing IR against this incident, I'm going to want to look at what can you tell me about the threat. So that's going to be the threat intelligence tab. So we can see here that the IOCs are mojobiden.com. Note we have two IOCs, yet we only triggered one incident. We saw these as related, so we grouped them into a single incident. That cuts down on noise, less alert fatigue. We also note that this does have a payload, right? Here are the malicious file hashes. There are 49 of these, right? Because this is ransomware. And we actually want to go a little bit deeper, right? So let me give you this example. Let's say this happened in a customer environment that had a Juniper firewall and Microsoft Defender as the EDR. So if I go to VirusTotal, I just want to take a look. Okay, you say it's bad. What do other security vendors say? So if we take a look here, we see a lot of vendors are getting it right. If you had a FortiGate firewall in this environment, you probably could not get to mojobiden.com. But remember, I said we're using a Juniper. So Juniper thinks this is totally fine. It will allow connections to mojobiden.com all day long because it sees nothing wrong with that URL. However, because in this case we would have integrated the Juniper response integration in the customer tenant, we will pass back a block to mojobiden.com to that Juniper firewall. We taught it something it didn't know. We enhanced its detection capability. We made Juniper better. And that's what it looks like with Lumu sitting in your customers' environments. We enhance your cybersecurity tools in a way, but because they often all never get it right. And so we're constantly finding that we're detecting things that the common tools are missing, firewalls, EDRs, and we're enhancing the capabilities to detect and protect your customers. Okay, we also give the analysts some external context, right? What is black matter ransomware? How does it work? How do I get rid of it? What steps should I take to make sure I'm cleaning it up and doing the IR properly? These are all external context items for the analysts to take a look at while they're doing the IR. I also want to point out we map every IOC to the MITRE matrix. The reason I think this is important is that by learning the tactics, techniques, and protocols that this ransomware, for instance, uses to get into the network, move around, try and cause damage. Remember, in this case, it's trying to encrypt files. It gives you some ideas on how to tighten security in the customer's environment. So let's just take it one of the TTPs. Let's talk about SMB Windows admin shares. If I see this type of attack and I'm mitigating it, one of the things I might want to do is just take a quick peek and see if anybody did something silly, like they set up a Windows file share where sharing is set for everyone and the security of the actual files is set to everyone full control. You are giving this ransomware what it needs to succeed. So this is telling them, hey, I've cleaned up everything, but maybe I should go back and tighten my Windows share security. So that's why I think it's important to look at the details of the MITRE attack matrix. So let's talk about what Lumu did and how quickly it did it. So I'm going to move back to highlights. One of the things I want to point out is that the operation timeline is present in every tab. You will definitely use this when you're reviewing an incident. The highlights tab is sort of a summary of this plus a little bit more. So let's talk about that for a second. In the highlights tab, we see when did we open the incident? When did we have the first endpoint contact the IOC? What was the last contact? What were the endpoints that were affected? How long did Lumu take to orchestrate response? And how long has the incident been open? So remember, in incident, I can choose to start working, or I can put in a comment like I'm taking a look at home desktop. I can keep commenting on things I'm doing. I can close the incident when I'm done. And I also have the option to mute the incident. So muting the incident will revert any blocks that Lumu performs against things like firewalls and EDRs. So in this case, as an example, let's assume again, we said we had Juniper as the firewall and we had Microsoft Defender as the EDR. What happened? So basically what happened was at 8:16 on May 15th, we actually detected the incident. In less than a minute, we would have orchestrated response blocks telling the Juniper firewall, you need to block access to mojobiden.com to any endpoint behind it, and any endpoint that had Microsoft Defender EDR loaded on it would receive back a block to mojobiden.com because Defender can receive IP, URL, and hash blocks, and it would receive back all 49 of these hashes, so it can now identify and recognize this ransomware if it was otherwise unaware of it. Now it knows about it, and it can stop that process associated with it. So oftentimes what's going to happen when you're looking in the timeline, we'll orchestrate a response and issue the blocks before the analyst even has time to look through the incident. That's how fast we are. And the point here is that no human can orchestrate these blocks as fast as Lumu can. And these are the same types of security things we would be doing as humans. We just can't possibly do it in a minute or less. So Let's go back to highlights, and I want to kind of highlight one more thing here. Let's take a look at the compromise radar and why I think this is important. So let's say the home desktop was the first endpoint that reached out. I assume that endpoint is likely infected. It's a good possibility, right? If it is, and we orchestrate the blocks and we still see contacts going out after the block response, that's a good indication we need to basically go take a closer look at that endpoint, make sure it's clean, because it's still trying to get out. We've blocked it at the firewall, but maybe Defender stopped working on it, or maybe it was turned off. So it didn't know about the ransomware. It's on that machine, and we need to clean it up. So if you see that happening in the compromise radar, it's important to take a look at that as part of working the incident. So that's really what a Lumu incident looks like. That's what setup of a customer account would look like when you're collecting the metadata and getting them started up. I really want to thank you for your time.